map, and it gives just the elevation of the area with respect to Baluchistan. So you can see this regional elevation on this map. So then study team, uh, then this is the map of Baluchistan. I leave it. Most of the people know the Baluchistan. It's a part of Pakistan. And this blue one shown on the right eastern side is the Kachi plain area. So this is in 3-4 districts are there. That is the Bhatti, Kachi districts, then Nasirabad and Jhalmaksi. So this blue area is this one where the cursor is. This is the project study area. Then this is again a map of Kachi Plains. So you can see its location has been shown in details somewhere here. So I will just these are the rivers. You can see Balan River, Nari River. These are the big river and Yob rivers. So you can see the rivers which actually flow in Balochistan area. So this is the Kachi plain. You can see that this is the foothills. These are the foothills, and in between this is Patfeeder Canal, and the Kachi Canal is also flowing along this Patfeeder Canal. The Kachi Canal is the new canal which is under construction, and it is the most lengthy canal in our country in Pakistan. It's about more than 500-kilometer line length, and there are 305 kilometers constructed in Punjab. At the moment, 40 kilometers are being constructed in Pakistan by under the all is the Kachi. Virgin land of Baluchistan.
But Isam, we are facing audio problem again, audio problem at your end. And it looks like that you have now disappeared from the Zoom. Sadia, if you are in the room, can you check with the speaker what is the issue now?
Okay. So slide को देखो या ये फिर गड़बड़ कर गया.
Can't see your screen now, sir.
फिर शेयर करें.
But Isab, you have to make sure that you share the screen and your presentation is on the screen, and then you can start moving the slides.
Okay, we can see your screen now. Good. Please go ahead.
This is not that starts from Tausabraj from here, and it will end here. It's about 500-kilometer long main canal. So this will be its irrigation system. All the irrigation system will be in Baluchistan. This has been completed in Dera Bukti area, and this is under completion. The area by this part will be irrigated about 100,000 acre. And the balance, these are phase 2 and phase 3. These the rest of the 2 phases will irrigate another about 600,000 acre area. So this is about Kachin. I leave the Kachin Canal. This is another branch. This slide shows the command area between foothills and the Kachin Canal project. This is our study area. You can see this area in phase 1. Then this is phase 2. Then phase 3. So this area is about 900,000 kilometers. Square kilometers. So this area is a vast area which lies between the foothill of Suleiman Range and the Kachin Canal. So all the water coming from the hill torrents that hit the Kachin Canal, and last year in 2022, about in Punjab, which is about 305, about 300 kilometer length of the main canal, that was badly damaged by hill torrent of the Punjab. Punjab has got very big hill torrent, and those damaged the main canal badly, and about 12 billion rupees estimate of rehabilitation has been framed by NESPAC that has yet to be implemented because of this scarcity of the funding. So next slide. You see, this is the phase-wise hill torrent. About 31 hill torrent, small, medium, and big one. The big one are the rivers that that flow in this Kachin Canal, Kachin Plains. This is all Kachin Plain phase 1, phase 2, phase 3. These are the coming out, emerging from this Suleiman Range, from in district Bhatti, Kolu, and also from the Ziyarat area, and ultimately they reach the Kachin Canal and hit it and damage it badly. So hill torrent phase 2, this is the different phases I have shown in the these maps. You can, I will give the slide to Sadia, she can share with you. Watershed of phase 3, these are next. So I'll now come to the background of this study. Why this study was allotted, why the Baluchistan government is interested to have this study. Because of, number one, enormous flood causing collateral damages, especially during the wet years. There are dry years in Baluchistan when there are droughts, but in the wet years, the abnormal floods hit the area and they cause abnormal droughts, abnormal damages. Second reason is abnormal droughts causing migration during dry years. And the flood of, if you compare this flood of 2010 and 2022, it caused damages of about $10 billion and $30 billion respectively. So these are the huge damages which are caused by these hill torrents in the area. So the Baluchistan government is interested to manage these hill torrents and use this water during the wet year for agriculture, for other purposes, for drinking purposes, for storage purposes, this and that. If you can read that, 2002, there was a big drought and thousands of the livestock were killed and the people migrated to other areas. Objective of the studies. Basic objective of the study was, number one, watershed master plan for Kachin Plain. That was our TOR, included in our TOR. Then there are some big river in this Kachin Plain which will come in the next slides, the consultant were asked to study the feasibility, to have feasibility of these rivers. These are Nari, Tulli, and Lehri River in the Kachin Plains. Then it's the next purpose is, next objective is to develop the agriculture in the area. Scope of work, scope of our study, that was actually given to the consultant. So scope was that includes the topographic survey, geotech investigation and foundation design, environmental and social survey, and logical study, proposal for intervention in these three rivers which have been mentioned above, watershed management master plan, and ON manual. This was the scope of our study, which we handed over, completed this study in 2024 in June. So these are the terms of reference. You can see these. We actually skip this one. You can see this one. Then the final product was inception report, draft PC1, hydrological analysis report, watershed management master plan for Murray built Bhatti Hill. It is misspelled. It is Bhatti here. Bhatti is written there. It is Bhatti Hill. Basically, it is all from small hills of Suleiman Range. Then Torrent basins, draft feasibility report, final PC1, final feasibility report, O&M manual, and environmental social impact assessment report. These were all final products which were submitted to client on time. That was in June 2024. Why this study? That was already I gave the reason that enormous flood with rapid frequency hitting the Kachin plains. Repeated damages are there. Use of uncultivated land by utilizing flood water. There is no canal system in Baluchistan except two main canals. One is under construction, that is the Kachin Canal. The other one is Butt Feeder Canal, which actually offtakes from Guddu Barrage. It's Guddu Barrage, and that irrigates the Kachin Plain, area of Kachin Plains, a part of Kachin Plain. So purpose of study already more or less discussed. Location of study area that has been indicated in the maps, and a strategic plan adopted by the for the exercise. So what we our plan was, strategic plan was, review the secondary data available with the client and other stakeholders, reconnaissance surveys and detailed surveys, assessment of hydrological data for flood water by different methods, field investigation for soil and geotech purposes, assessment and suitability of the intervention, to design of intervention, costing of intervention, economic and financial viability of the proposals, and then environmental and social impact assessment. So this is our hydrological study, watershed management master plan. For as we were to submit the master plan of the watershed management, that covers area between, I have already explained that is between the foothill of Suleiman Range and the Kachin Canal. That is about 900,000 square kilometers. Map of Kachin Plain. Again, this is map of Kachin Plain will show some hill torrents. So you can see that one, that the flood volume and discharges for 50 years. So how our hydrologists proceeded? They divided the Kachin Plain in 7 areas, 7 sectors. That was sector 1, 2, 3, 7. And then you can see this, if you zoom it, so you can see that there has been dots which indicate the nodal points. That was their strategy. They divided the area, all the 900,000 square kilometer in 7 areas, 7 areas, that is called unit area, unit 1, 2, 3, 4, 5, 7 units. They divided it. Then they fixed nodal points. The nodal points is defined where the hill torrents of different capacity or discharges merge, and then you can use that water, that merged water, for the development of different interventions. So those are called the nodal point. This is very important to understand how the hydrologist, while getting uh, this hydrology, because I will just clarify that we were not having any hydrological data or study about these hill torrents. So the consultant purchased the satellite imageries of high resolution that the contour width was not more than 5 feet, and then use the excuse me, available data of rain data of different station in the area, and then they worked out the discharges of these hill torrents. So they adopted this methodology to work out the discharges of all the hill torrents, significant hill torrents, so that we can reach some figure that this much water is available. And they work this water availability for different return period, starting from 10 year, 15, 20, 30, 40, and 50, 100 year, up to 100 years. They worked out the discharges on these nodal points with this methodology of imagery bought from international market and used for working out the discharges on these nodal points. So because of this study, this 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 viability of this study is dependent on the availability of water. How much water will be available at different points? So that is very important to understand. So the consultant divided this area into 7 units. Unit 1, 2, 3, 4, 5. You can see in the slide the units 1. This is unit 1. This is unit 2, unit 3, unit 4, 5, 6, 7. So 7 units are there. So they adopted this methodology because there are also security issues in Baluchistan. Everyone understands the security situation in Baluchistan is not that is not up to that level that the people can freely move in the area, and so we were have to adopt some other method instead of going into the field and getting the information and data and also observation of the flood discharges. So this methodology was adopted for working out the hydrological analysis. I think I have been able to clarify this point. So hydrological study methodology, I have already explained nodal point, this and that, and so you can see this slide is, I have skipped this one. This is the table for, you can see the water units. They divide, actually these were called water units. So can you see in the first water unit, there are about more than 7 nodal points. And it is a mix up. So you can see the nodal points there, NP1, NP2, NP3, 6, 7. And then NP next unit is 2, that first has 7. The other one has 7. The unit 3 has about 10. And 4 has 3. 5 has 8. And 6 has you can see there are a number of overall it is about 57 nodal points. But there are these, why, how they selected these nodal points? The nodal points were selected on the basis of the population of the people living near these nodal points. The population, which was about 500 people, that nodal point was taken into this study, and the nodal point where the population was less than 500 people, that was left. So that was left for next phase, so that if we can uh, implement this uh, plan in future, because this is also part of master planning. That master planning will continue for 10 to 15 years. So this project, if implemented, if this master planning is converted into a PC1 and a feasibility study is done, then the government may approve a PC1, and that plan can be implemented in next 10 to 15 years. So this master plan. So how this water hydrology study was done, the HMS method was adopted by the hydrologist. You can see this slide. This is thus model. This model was adopted to identify, to estimate the discharges of the nodal points. Excuse me. So this is because of because of calculating the hydrology of all the hill torrents and nodal points, we need measures. Then we need the inventory of the rain gauge station. So this is all the rain gauge station present in the area. And we have got about 60 years rainfall data for these rain gauge station in the area. So minimum it is about, I think the hydrologists best know, the 30-year data is needed. So we have about 60-year data with Baluchistan government and also with WAPDA. So they use the data of these related hinterlands only for estimation of the discharges of the hill torrents. So these are the rain gauge station details. This is very interesting graph. Rainfall, climate change impact. You can see in year 1969, the intensity of rainfall was minimum, less than 100 in the area. But in 2019, you can see it is more than 200. So this graph is very, very important, that shows the impact of the climate change in the area. So huge water is coming from the hill torrents, and it is badly impacting at the moment because there is no management of these hill torrents. There is no proper schemes available that can utilize this flood water. This is very, very precious water because Baluchistan is scarce of water. Scarcity of water is there in Baluchistan, and there are so many droughts in the Baluchistan. So in the drought days, yes, you can use this water, which is huge in quantum. So this is a very interesting graph. So this is again a water unit and their discharges. You can see, and water area also given in square kilometer. So this is interesting information for everyone. So the volume is given, the discharges are also given. The hill torrents are about 31 in the area. So I think the list I can provide you later. All the hill torrents have not been given. The name of all that have not been given, but the overall discharges have been given. So this is unit wise, water unit wise, volume of cumulative water, acre feet, and also in volume. This one is hill torrent wise. Sorry. This is hill torrent wise. This is overall cumulative. Overall volume in acre feet. This is in acre feet. So you can see. So this is the existing number of nodal nodes. Kitne hai na? How many nodes are there? 4, 5. So unit wise each details are given here. So I leave different units are given here. So you can go through it. This is water volume, water unit wise 50-year return period. These water volumes are given on 50-year return period. You can see unit 1 has got the least one and the highest one is water unit 7. That is given in acre feet. So these are the water volumes of these water units. These are total water units, not hill torrents, because hill torrents have this water unit have had so many nodal points and so many hill torrents. So this is overall water units volumes of water. What could be done in master planning? We propose these intervention in Kachin plain based on water availability for master planning. That is the check dams, diversion and dispersal structures, infiltration galleries, small gabion structure to check, and soil gradation, forestation, terrace irrigation, on-farm interventions. So there could be so many others. So these are what the identified intervention for water management, watershed management, master planning. Now, this is all about watershed management, master planning. But if you go in the next, this water unit 7, you see that there are highest volume of water available. So in this area, water unit 7, actually there are 3 rivers that run in this area, which actually have a lot of numerous number of tributaries which contribute to these rivers. So the government of Baluchistan asked the consultant for feasibility study of the water available in Nari, Talli and Lehri rivers. So you will see that how much river water are flowing in these during the rainy season, during the floods. So then we went for the study. First, we submitted the master plan. Then we went for the feasibility study of these 3 rivers. So this is about the feasibility study of these 3 rivers. So you can see again a map of feasibility study area. These 3 rivers are indicated there, and all the hill torrents. You can see, if you zoom it, you can see the hill torrent coming to these rivers. So this is a map of the biggest one river in the area is Nadi. So you can see this Nadi river map. This is a map of Talli river. I leave it. Location map of Ladi. I leave it. Now you can see the observed discharges versus calculated discharges, 50-year return period. So you can see Nadi river, the observed discharge. These discharges are observed in about 20 years back. Then they and WAPDA was responsible for observing. Then they stopped observing the discharges of at site discharging of these rivers. So we have old data for that. So this is this figure 106,000 cubics. It is about 300 cubics. This is very old data. However, if we work out the discharge for 50-year return period, that was about 120,000 cubics. So similarly, you can see the Talli River. Talli River has got 33,000 observed discharge, and it is very near to 50 years. And then it is Lehdi River, Its discharge is about 51,80,000. It's also on the 50 year is also nearest to that. So these are the discharges. So on this is a river-wise structure already constructed at site. The government of Baluchistan have already constructed a number of structure on different rivers for diverting the this flood water for agriculture purpose. So you can see there are so many structures. This is the discharge 50 year 36 300 and 386 cubics. Don't mind, there are some the units are sometime it is Q6, sometime it is cubics. Kindly don't mind it. You can convert it. So then there is structure that is at Mithidi. After Mithidi, the off-taking discharge off-takes, then the balance is left about 2,500 cubics. Then it reaches Haji Shahar. So 57 cubics is actually diverted, and this is left. You can see that you cannot equate it because the water spills over in the area also. So the water reaching you, if you just directly plus minus it, it will not work at all. So a lot of water spill over into the area because these are the rivers. Then it is Tuk, then Ghazi, and then you can see, and ultimately Jalal Shah. And after Jalal Shah, you can see that 322 cubics discharge is still left, which is unutilized. So that discharge, that matters, and that travel towards the Kachin Canal and Patfeeder Canal. At the moment, in phase 3, the Kachin Canal has not been constructed. It is under implementation. It may be constructed in next 10 years, but ultimately, presently, it hits Patfeeder Canal, which runs parallel to Kachin Canal. So you can see about if you multiply by more than 3,000 or 10,000, I think it is. If you multiply by 35 point something, so that is more than 10,000 discharge that travel towards the Patfeeder Canal and causes a lot of damages there. Then this is the second river, Tali River. You can see all the structure there. Few of them are to be constructed and few are existing. Similarly, it was the case in Nari River. So you can see the balance sheet there, how the discharges will be used and are being used. And the balance discharge ultimately going towards the Kachin Canal or Patfeeder Canal. You can see this is the Ladi River. Similar, it is the same thing that the overall discharge was 1,400 cubics, and then it is used on every structure, and ultimately it goes towards the Kachin Canal. The part of study was also to geotech analysis and soil investigation. So we outsourced this component of the study to WAPDA Central Lab, and they conducted this, and we got this report from them and handed over to the client. And the main point of the investigation are given here. Total number of site investigation were 5. Depth of borehole were 50. Borehole on Tali River 3. Borehole on Nadi River 1. Borehole on Lehdi 1. So this is the soil, how we proceeded for soil investigation. Minimum soil investigation was done because the number of structure we proposed was overall, I think, 7 structure for PC1. So these are the result. Depth of coloration is given there, depth, and then cohesion C value is given there. Angle of internal friction is also given there. Unconfined compression test results are an unconfined compression strength, failure strain, etc. So geotech people may be more interested in these values. Environmental and social studies. All the World Bank projects where the World Bank and the donor, Asian Development Bank and other donors, they always ask for social environmental impact studies. So we had a team there, and if you see the first slide, the experts team that include also the sociologists, sociology experts, environmental experts. So they went into the area, they interviewed the people, they conducted survey there, and ultimately they submitted environmental and social impact assessment report, and we finally submitted to the World Bank and to client, and that has been accepted. So that is ESA report, environmental social impact assessment report. Then mitigation measure for the as some hazardous type of impacts were indicated in the reports. Mitigation measure were given, then proposed. That was the social and environmental and social management plan was submitted that indicated the mitigation measure, indicated from the hazard point or the any negative impact of the social and environmental uh, things. So this plan was also submitted to World Bank, how these will be mitigated. So we ultimately, because the study, the feasibility study was just not to feasibility study, it was design of feasibility level of intervention proposed, and finally the detailed design of the proposed structure or intervention on these three rivers. So we ultimately finally proposed different intervention on these three rivers as a part of our study, and at the end we submitted a PC1 to client and World Bank, which has been approved by Baluchistan PWD department, Planning and Development Department, and has been submitted to federal government for approval. And I think it has been cleared by CDWP, and finally it will go to ECNIC for approval. The World Bank has already committed $100 million fund for this project, and this project actually has two components. One is for water supply quota. So $60 million is for this flood mitigation measures, and $40 million is for quota water supply. So World Bank has already committed funding for these projects. So interventions, so selection criteria for intervention, you can see, you can read. These are all criteria given in the where the water is available. The biggest criteria is the availability of water. How much time this water is available. If the water is not available, there is no scheme, there is no intervention. So I will just emphasize on availability of water. And then secondary thing is this investigation for soil, this and that. But the most important is availability of water. Availability and intensity of water. How much water and how much volume is coming there. So that is the most important thing. So I will leave other, you can go through it. Proposed intervention on these rivers are: number one, dispersal structure. The dispersal structure or diversion structure are the structure where you build a cross regulator and then an off-taking channel, so that can irrigate the area by flood water. So these are all flood water channel. So on these three rivers, the farmer are the best judge in the area. They have built earthen dikes. They build earthen dikes during the flood and try to divert the water into their field. But if the intensity of water, if the volume of water is very high, then these dikes, earthen dikes, are collapsed, and sometimes they lose their tractors, they sometimes lose their life. So they try to irrigate when the volume of the flow is very small in the hill torrent. So they are the best. So we have adopted the same thing in our interventions, and we are building now the concrete structure for the farmer. So they have not to build their earthen dikes across the river to divert the water. So these will be gated somewhere, and some will it will be ungated one. So this is the by hundred and hundred from hundred and hundred years the farmers are using this techniques in Punjab, in Baluchistan, and they are irrigating, but they were unable to divert water when there are high floods. Only small water of torrent can be diverted by their earthen dike. So we are now constructing the reinforced structures across the river and for head regulator of their canal so that they can easily divert the water towards their field. So by this, the irrigation will be increased by 70-80%. If it was being irrigated about 30,000 at the moment, then it could be irrigated about 100,000. So we have actually adopted that, use the wisdom of the farmer. Then there are another intervention, because this is flood water and it comes and goes away. So we have proposed storage pond, flood water. On the main river, we have proposed to build head regulator for a canal, feeding canal towards the pond, which will be constructed on an area of about 1 square, that is about 25 hectares. So the water will be diverted, and its proposed depth is about more than 15 feet. So that can be used during non-availability of water for irrigation and drinking purpose also. So that is another intervention we have proposed in our feasibility study. Embankment protection, yes, along the river we have also proposed flood embankment structure from all the cross-regulated upstream of 2 kilometers. 2 kilometers upstream on every structure. Then there are stone stud for diversion of the current of the river, and then shingle top. All the embankment will be shingle top, so that the officers visiting the system during the flood, they can safely travel on the embankments, because it is very slippery when there is rain. So we have proposed shingle top on embankments. So these are the intervention proposed in the feasibility study for 3 rivers. So this is a design criteria for hydraulics. You can go through it. All the engineers know that. I will just say that we have adopted federal flood commission criteria for freeboard. That is 1.5 feet to 1.75. Sorry, factor of safety. And similarly, we have adopted the same standard of freeboard for all the protection work of embankment, that is 5 to 7 feet freeboard from the water level. So you can see, this is our exact gradient, how it was kept, and floor length. So every hydraulic engineer knows that. So we not only design that, we also run on computer model HECROS for determining of the highest flood level which may take place by running the discharge of 10-year, 25-year turn period, 40-year turn period, 50-year turn period, and 100-year turn period. 100-year turn period. So all the discharges were run on HECROS, and the flood limits were noted. So all that elevation has been given in this. I have given this slide for only one, only Khatur, one structure. There are so many structures. So this is how the across, this is across cross section. You can see that. This is the second for Safi. So every hydraulic engineer must be interested in this, in these slides. This is again Safi axis. This is the classical Safi. Design criteria structural. So you can see the structural design criteria. So this is given the apron standard are also according to FFC, and the design apron, this and that, because there are so many apron upstream, downstream of each and every structure. Also similarly, design of embankment has got its standards, and we have followed those standards. This structural engineer may be interested in these. And these are the name of the intervention on different river. Nari River is Khatur, Jalal Khan, and then Sharkal, flood embankment, and then drinking pond, 7 number, and mitigation pond, 4 number, on-farm water management interventions are in addition to that, and a frustration of 50 hectares. So these all structures will be, have been taken in the PC1 and the feasibility study, and the government has approved it, and I hope next year or during this financial year, this may be implemented at site. Then intervention on Tali River, you can see these are the intervention where we have to construct these hydraulic structure, the concrete hydraulic structure. You can see, and the mitigation pond, drinking pond. There are two types of ponds. One is flood mitigation pond, the other is drinking pond. Drinking pond are very small in their size. So they are about 1 acre, 1.5 acre, not more than that. So these are the interventions. These are the intervention given on Daddy River. This is, you can see a picture of pond, feasibility of ponds. This is very interesting graph, probability of sedimentation of ponds, life assessment. So we try to assess the life of the ponds because heavy silt load is coming from these hill torrents. So you can see on this side, it is the percentage filling. This is the filling of, blue one is filling of silt. And this is the red one, the brown one is actually capacity of the pond. So when these are the number of filling. These are the number on x-axis, there are number of filling. Number of filling means actually, if you see the history, in the chabi nahi hundi, eve hundi chabi hundi. So under button was started. Yeah, button under push button. So you can see that when number of filling means if the hill torrent comes 10 times in a year, it means 10 fillings. If number of times that river flows in a year are 20, it means 20 filling. If 5 in a year, there is a drought condition, 5 in a year, it means 5 filling. If the fillings are less, the life is more. If the fillings are more, life is less. So you can see the number of filling, if 50% is about 17 or 18 number of filling, the pond will be 50% filled with silt. So we have tried to assess the life. So after 57, about 50 years, the pond will be filled 90% with silt. So this is an assessment. Exactly what will happen because all the time the hill torrent actually flow with different content of silt. So that will depend upon the silt content coming in each turn of flow of river, and the number of flows in a year. So this is a graph which we are trying to assess the life of these ponds, which is very important because these ponds are going to cost about 50 to 60 million rupees on each pond. So reduction story. So this is same thing that has been given in the narrative form. You can see that in you can see that the large pond will be 50%, 90% siltation is given at different level. Loss of water in storage ponds. So this is a table which gives the loss of water in storage term with siltation. So you can see this how it will through seepage, because the World Bank asks us to kindly assess how much seepage will take through these ponds. So we use Darcy's law for assessment of the seepage. So this is, you can see this through this table, and seepage discharge in cubics. So it has been worked out through the cross section of the this pond, because pond is constructed by constructing a this all along embankment. Embankment has been constructed all around the uh, these ponds. So we have proposed water level is there about 50 feet or 100 feet, and try to use the Darcy's law. So this is in narrative form. You can see this is given all the how the seepage sedimentation and seepage losses and water pond. These are the conclusion about that. So you can go through it, and if there is question, I can then answer. Try to answer. So this is the recommendation. So these are recommendation. There should be continuous removal of silt in 1 year, at least once or twice in a year. So that will increase the life of the ponds. Disposal of residual water. Now finally the question is still, if we use all the filtered water with these intervention, that will be only total water coming from these rivers 50 years will be 200,000 cubics from all these hill torrents. So we will be able to use only 60,000 cubics. No, not 60, I think it is 40,000 cubics. The 60,000 cubics will still go towards Kachin Canal or Patfeeder Canal. So that will be a very alarming situation or damaging situation, that how we can control. That means we need a lot of other intervention, implementation of master planning, so that we can minimize the water going towards Patfeeder and Kachin Canal. So these are the final disposal of residual water. This can, you can see unit wise water going towards from Ravi. This is the Nadi River. How much ballast water? Here it is the ballast water. This one is the ballast water. This is the highest one volume. That will become 50 years in that period. Sorry. Oh, shit. There is again some problem. So this is Tully River. You can see the slide. This is Tully River. This is Ladi River. This is overall 3 river balance. This is the maximum one, and this is the minimum one, that cumulative effect of these this water, this one. This diagram shows arrangement plan for disposal of flood flows hitting Kachin Canal. Actually, we have been working on Kachin Canal also, and our team of the engineers, they propose different options for disposal of this balanced water, this residual water, so that it cannot hit the Kachi or Put feeder canal. These are, you can see all the hill torrent named here. All 31 hill torrents are named here. So in phase one, this is from here to here, it is phase one. This is Kachi canal, this is Put feeder canal. So phase one hill torrent, they have given so many, their proposal that these should be disposed of here in a river, and ultimately a Namal lake, or it's a lake here in Sindh. And similarly, phase two will be also transported here, will be actually sent to this side. And phase three, water will be actually used up there as a river, and ultimately it will go to this lake also. So there have been a study which the MMP have conducted and given different option for disposal of this residual water, and that residual water have to be disposed of till we can actually utilize this water in upper for in the upper areas, or in the catchment areas, or in Kachi plain. We have to have some arrangement to safeguard the people of Sindh, property of Sindh, Baluchistan. But for this, there has to be consensus between the two government and the federal government, that is the Baluchistan and Sindh government, and the meetings are going on to uh, actually resolve this issue, but it's still pending. It's very difficult problem. It's very, very complex issue. Stopped. I'm sorry. And again, problem. Sorry, I can just give a few things because slides are not moving again. So it's so many. It's a very, I think the lecture has gone very long time now. Now, after that, this was all final disposal. For all these interventions, we prepared design, all these interventions, the structural structure, bond, this and that, and then we had estimate of that. That is the PC1. The people, all of you, I think, know about the PC1. So we prepared a PC1 that cost about 17 billion rupees, which has been submitted to the government, which is financially viable and also economically viable. The EIR is about 18 to 20% for this project. So I think this lecture have सब चलिए आ गया, लेकिन it's not moving. It's not moving at all. So but just to show you, okay, this is there. Ultimate disposal is, it has been shown in this map also. Estimate, cost estimate. You can see the cost estimates. So these are the different cost estimates. It's 22 billion rupee is for feasibility structure. But when we did the PC1, we dropped few of the structure because there was a limit. $60 million was available. So $60 million means 17 billion rupees, about 17 billion rupees. So we actually have to drop few of the structures. Then this is phasing. So 24, 25, this is, you can see the phasing, how the work will be done. This implementation schedule and primary economic and financial analysis. You can see EIR base model and this and that and different with sensitivity analysis is also there. This is NPV values and benefit cost ratios. Thank you very much, everyone there. I'm again sorry for these technical problem. I think I have been able to explain this project, and now it is question answer. Okay, thank you.
Thank you, Bhatti sir. I have one question which is from Kashif Sajjad. He's asking, is it 50 years? Is it 50 years return period data enough? If data not available, we can interpolate some by some watershed models like UBC or other.
Yes, this one, actually, this was desired by the client. And data is available only for rainfall, but the actual observation of the discharges of filter is not available. For few years in 60s, a few data was available. But after that, after dropped observing the data of filter, so I understand that 50 years is enough.
That was the only question I had. If there is any other question with the audience, kindly you can type it in the chat box and I will read it. So kindly do it very quickly because we are very tight with the time, and I have to say make some announcements also, and after that we have to close. So any questions, please type it. Rizwan, if you have to say something, kindly say it so that I can, after that I can make the announcement and we can conclude.
I only wish to contribute a bit on the last question that you have addressed. That is the question of return period. I think given the change in the climate that we are facing around the world today, it is very difficult to predict hydrological factors on the basis of the past data. The behavior of the climate has become very erratic. Is that correct, Bhatti sir?
Yes, 100%. I agree with you.
Yeah, this is the only contribution I wish to make. Otherwise, it was a very good and very informative lecture.
Okay, thank you very much, everybody. And I have to, since we lost some time in the beginning, and I have to now close this, conclude this session. Again, first, my apologies that very unfortunately we lost time in the early session. About I think 33 minutes we lost because of this technical issue. Inshallah, we will take more care next time so that this issue does not take place. And now the next lecture is on 14th September 2024. 14th September 2024, and it would be of great interest for the young engineers because the topic is, what do the employers want in young engineers? I repeat, what do the employers want in young engineers? And our esteemed speaker is Engineer Suhail Kibriya. So I hope the young engineers, inshallah, would attend this lecture on 14th September. Today's lecture certificates can be collected on 22nd August 2024 from 14A1 Block P, Model Town Extension. And before coming to the office, if you want to call, the person is Ahmad Akram, and his cell number is 0347462511. I repeat again, it is Ahmad Akram is the person who will give you the certificates. And before coming to the office, if you want to check his availability, it is 0347462511. Now, thank you very much, Bhatti sir, for this enlightening lecture.
Thank you. Thank you. Shukriya.
Your shield and your certificate, inshallah, Sadia will send you by the special messenger or by courier mail in next, let's say, 7 to 10 days. Now, before I conclude, I want to express my heartfelt appreciation for my co-host Rizwan Mirza, my coordinator Sadia Naveed, and my IT person Hasnan. They work tirelessly behind the scenes and contribute significantly to the quality and seamless execution of this live transmission. This transmission, for your information, was also broadcast on Facebook today live. So thank you very much. I will see you on 14 September 2024. May Allah bless you all. Allah Hafiz.
Thank you. Allah Hafiz.